Hi guys, I'm Lee. For our physics class video, we fired an arrow from the bow, and we will be finding the final velocity of that arrow, and to do it, we'll be finding the time of the trip, the displacement in the x direction, and the y direction respectively.
Here's our group, and our adult walking away from us.
Just someone tell me when to stop it.
Alright, Isaac's gonna be shooting the bow, and Lee is gonna be timing it. It's all on Lee.
Alright, I got this.
And our adult supervisor.
Which we have.
And I'm somewhat standing behind Isaac. 90-degree angle, or 0 degrees, or whatever. Yeah. Cool, there it goes. Okay.
Crap, that start.
What?
My watch
Oh my God.
Press the button.
Lee!
We should just go get this.
Yeah.
Make sure it actually starts this time.
Alright, here we go. Dang. What seconds? 3.
Now go measure.
And our data. You can't see.
We have to measure individually so we don't little arrows.
Yeah.
Make it also fire.
But no, Isaac, go,
So it's just about I'll hold this here, and Isaac, I think.
Yeah, and Ben, are you even going towards the arrow?
We need to make it turn.
Yeah, there it is. There's the tape measure. How far is it? So far.
It's approaching the end.
That's probably it. Yeah, that's probably it. How many is that? 100? That's 100 right there.
We got 100 feet. I'm reeling it in.
Yeah, 100 feet right there.
100 feet right there. Let go of it. Let go of it. Thank you.
Oh,
It's
dang.
gonna take forever. I hate this. This is terrible.
Dang it. Where's the other battery? No!
The self-retracting one would have been nice.
Yeah, well.
God hates me.
Yeah, we got a long way to go. Hey guys, if you find a battery, give it to me.
This is terrible.
Keep going. And don't break that. God, dang it, Ben, you're going the wrong way. There. Go. What the?
WTF, mate? Hey, let's watch the language.
Oh gosh. What the hell? Ben, you're making it worse.
Crappy measure is making it worse.
You're making it worse.
I hate this. Oh, it's only like 100 yards away now.
There's ends. Yeah, I probably dropped it on the way back.
Better ways to do this.
So it's like right here. I'll hold it, dang it.
Freak. That hurt. Oh.
Smart one, Ben. No, it's over there. To your other side. Yeah. It's over there. Yeah.
58 and an inch. 158. Actually, let's make that 150 down to an inch. We're like 10 inches.
What is this?
Hi, my name is Zach, and I'm here to tell you that when you shoot an arrow from a bow and neglect air resistance like we did, the acceleration in the x is always 0 meters per second squared. And that is because there are no forces acting on the arrow in the x direction.
Hello, I'm Isaac, and I'm doing acceleration in the y direction. When you shoot an arrow at a certain height, it will go towards the Earth at 9.8 meters a second squared, because we're neglecting air resistance and we're on Earth.
Hi, I'm Elizabeth, and to find the displacement in the y direction, we measured the distance from the arrow to the ground.
Hi, I'm Chris, and to find the displacement in the x, we used a 100-foot tape measure to measure from the tip of the arrow to the tip of the arrow in the ground. And after we figured out the feet and inches, we converted those to meters to get our standard unit for our projectile problem.
Fascinating.
Well, hey there, I'm Ben, and I'm here to guide you through the most scintillating part of science, which is averaging. Now, this is often underlooked, but we're really going to pay attention to it today because it's vastly important. Now, we started out by finding some values through calculations, and our first one we found was 36.83 meters per second, ladies and gentlemen. Now, that's the final velocity. Now, the second one we found through calculations was, I believe, 34.08 meters per second. That's also fantastic. Not much difference there, but moving on to our third one, probably the best, and our final is 28.49 meters per second. Really an outlier, guys. We're going to make some magic happen. We're going to make that all go away. So, write that down real quick. Now, the way averaging seems to work in this part of town, at least, is you add everything up. Since we have three things we're adding, we're then going to divide by 3. And this is really going to make some cool stuff go on. So we're going to add all these up, and we're going to get something, I believe, like 99.4 meters per second. And now since we have 3, that is 3, guys, we're going to divide by 3, and we're going to get something along the lines of 33.13 meters per second. Now that's great, guys. So sum everything up. We got 33.13 average final velocity here, and that's in meters per second. So have a good day, and that concludes our averaging portion.
Hi, I'm Wee, and I'm here to introduce you the boring world of math. Our first equation is time times the velocity in the x direction, which will give us the total displacement in the x direction. Our next one is the displacement in the y direction times the acceleration times 2 plus the initial velocity in the y direction squared. That will equal our final velocity in the y direction squared. Our final equation is velocity final in the x direction squared plus the final velocity in the y direction squared, and that will equal our final velocity squared. Up and right is positive.
Alright, here's a sample problem. We have our variables right here. Time equals 1.33 seconds. 159 feet, which we converted into meters, equals 48.4633 meters, which we rounded to 48.46 meters in the displacement of the x direction. Our acceleration in the x direction is 0 meters per second squared because there aren't any forces acting upon it. So here's our work here. Velocity initial in the x direction equals velocity final in the x direction. The displacement in the x direction equals velocity of the x direction times time. So the displacement, which is 48.46 meters, equals velocity in the x direction times 1.33 seconds, which we get to equal 36.43 meters per second for velocity in the x direction.
For the second half of our equation, we found all of the variables in the y direction. Time is the same, 1.33 seconds. The displacement in the y is negative 1.499 meters. The acceleration in the y direction was negative 9.8 meters per second. Initial velocity in the y direction was 0 meters per second, and we were trying to find the final velocity in the y direction. We chose this motion equation. Velocity final in the y squared equals velocity initial in the y squared plus 2 times acceleration times displacement in the y direction. After plugging in all of our variables over here, we found that final velocity in the y direction equals 5.42 meters per second.
Due to unforeseen circumstances, we have lost 3 members of our group, but luckily we still have enough people to carry this out. Taking the final velocity in the x and the final velocity in the y, you have 2 sides of a triangle. To find the third side, which is our final velocity, you take the Pythagorean theorem, or in this case, final velocity in the x direction squared plus final velocity in the y direction squared. That will equal our final velocity squared. Plugging in all of our stuff, and here's our final answer of 36.83 meters per second.